Warm greetings and wishes to all the students and friends. Good morning to one and all present here. Today we are going to see about the video lecture on how to solve the problem in the case of method of section in truss analysis. You know that method of joins already explained in the previous video. In the case of method of joins, you are finding the members forces in all the members of a truss by applying the two equilibrium equation, that is a summation of all the vertical force are equal to 0 and summation of all the horizontal force are equal to 0, that is sigma fx or sigma v f sigma fx, that is equal to sigma h is equal to 0 horizontal equilibrium, and sigma fy is equal to sigma v, that is equal to 0, that is all the vertical forces are equal to 0. So by using this equilibrium condition, you can solve the member forces in the case of truss, that is all the members. Then in the case of method of section, a given truss is there, say there are 10 or 15 members are there. I'm going to find 2 member force or 3 member force out of 13 or 15 members only. So in that case, so the easiest method is method of sections. You have to go for a cutting plane 1 1 and 2 2 3 3 etc. for to find any one member force or any 2 or 3 member force, different section plane you have to do, and you have to apply the vertical equilibrium, horizontal equilibrium, and moment equilibrium. So here moment equilibrium is also applied to find the unknown forces, either 2 forces or 3 forces or sometimes 4 forces if you have a 25 members is there. So now I'm going to take a simple problem. So it consists of the height of the truss is 3 meter and the total span of the truss is 8 meter, which have shown in the diagram like this. You can see. So this is the given truss for the method of section I have taken. So you can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 8, 9 members are there. So out of which I am going to find the vertical member CF and the inclined member, right? I have shown the section also, right? 1, 1 and 2, 2 section plane. The member you can see B into F, right? So the right FB or the force number BF. So we have to use the 3 equilibrium condition like sigma equal to 0, sigma h is equal to 0, and sigma m equal to 0. So here we have to find the reaction. If you are finding the reaction, right, for this test carries right 20 kilonewton at the joint F only, downward only. There is no horizontal external forces, so only the vertical load is applied. So this truss, which is of 2-span box girded truss, which consists of right 1, 2, 3, 4, 5, 6, 7, 8, 9 member forces. So it is a perfect truss only because it will satisfy m is equal to j minus 3. So now, so you have to find the unknown force, right? So you have to find the unknown force, right? CF and BF. So you have to apply the equilibrium conditions. Before that, you are finding the reaction to come as right VA and right VE, or at the support condition we are getting as 10 kilonewton, right? I have given the calculation also. Then in the case of right to find the forces in the member C and F, first I am going to find, then I am going to find the another member force, right? C BF. So I call it as F BF and F CF. You take a section I have shown in the diagram. You are applying the vertical equilibrium, horizontal equilibrium. You are getting the force unknown as you are getting as right. It is point of 8.67 kilonewton in the case of BF forces, and in the case of CF forces, we are getting 15.68 by applying the conditions of sigma v equal to 0 and sigma h is equal to 0. So like that, we can find any number of forces. Here also in the method of section, we find all the forces members, but it will take time. So it is a cumbersome method. So in that case, we want to find all the force member, you have to apply the method of joins. If you are able to find 3 or 4 forces out of say 15 or 20 members, in the case of truss, we can go for the method of section. So method of section is very simple method. Only a very few member force has been asked in the case of truss analysis, which consists of 20 member or 30 member or 100 members. So we have to take a corresponding section plane 1 1 or 2 2 or 3 3 such that only two unknown should be cut in a particular line. So where there is two members are cutting joining each other, the moment equilibrium will be zero at that point. So it is easier to solve the unknown vertical member or inclined members or the vertical member force if you are applying the corresponding section plane. So only thing is you have to choose a cutting plane section so that only two unknown members should be forces to be determined. If you're having 3 or 4 unknown in a particular cutting plane, it's very difficult because only 3 equilibrium equations are there. So that is the thing. You have to keep it in mind. Thank you very much for patient listening. So this is about the method of section, how to find the force in a few members, either 2 members or 3 members. I have taken only 2 members only in a given box girder, which is of 3-meter height and 8-meter span, which consists of 4-meter, 4-meter, and applying a 10 kilonewton load at the joint F. So I have not applied horizontal or inclined forces. Similarly, you can apply the horizontal, vertical, and inclined external forces. So to determine the unknown forces in a few members in the case of method of section. Thank you very much for patient listening. God bless. Valga Vaiyagam, Valga Valamban. So in the next video, we are going to see about for a 3D, for a truss analysis. In the case of 3D, you have to go for a method of tension coefficient method, or you can go for a graphical method. So that we can see in the next video lecture. Thank you very much. God bless. Valga Vaiyagam, Valga Valamudan.